Expensive camera. It's my wife's expensive camera. If I get enough of it? You get enough of it. Uniform probability distribution basics. Okay, let's talk about what's going on. So if that's from 1 to 7, how high does that have to be?
6.
You go 7, take 1, which is 6.
Divided by 1.
Oh, yeah.
Divided
One.
by 1.
Is that the wrong way? How do I get the 1 divided by that?
6
So then you got the 6 times the 6 will get you an error of 1. What's EX without thinking? Too slow.
What? Oh, 4.
4. Yeah, and people talk formulas and all sorts of things. What's the variance?
Alright.
What's I'm going to tell you? B minus A squared on 2. 12.
12. Is the 12? Is that part
Is
of
it
the
just
formula?
always 12?
It's always 12. What?
I've never mentioned that one to you before.
It's always 12.
Yep.
Why?
In the back of my mind.
It's 3.
Well, I can put you on the video proof I've just watched on YouTube of proving up. I feel like coming up on my own, so I don't like that.
So it is
3.
Now we're going to not prove to you it's true, we're going to show you it's true, ready? So I could have done, I thought about, do I show you that first or do I go through the integral first? And I thought, no, we're just going to do this first, ready? So 7 take 1 squared on 12, which is 6 squared, which is 36 on 12, which is 3. When I first taught this topic, I didn't know that even existed. I didn't find anywhere on the internet. But in one of the waste reports, I was talking about you could use that instead. So let's get the integral instead. So what's the variance as a formula?
it's like
You know what it is?
B, A, and then f of x. Something.
So I'm going to say fx, and I'm going to write this time. You know how I like writing words that are going to get a picture in your head? I'm going to write deviation squared. I'm going to bother to write that J. It says, doesn't mean you'll understand it, but I'm going to write it down. So what's that? Fx times what?
The sigma.
X minus, in other words, deviation is how far are each of the values from the mean. How far are each of the numbers for a continuous curve from the mean, which we don't call the mean, we call it the x. That's your formula.
What's f of x?
A function for this line here. So what is the function for this line? F of x is
The 6.
a 6. By the way, a minute ago I was mucking around with 1 on B minus A, and the proof comes from the 1 on B minus A.
Oh.
You end up with this 12 always being there, which is rather interesting. So our function is integral, our integral is a 6th of x minus, really obvious for this one, 4
Squared.
dx from where to where? 1 and 2.
7.
7, so we got, how quick can we do it? We got a 6th of x minus 4 cubed on 3 from where to where? 1 to 7. So you could simplify, you could go, well that's an 18th of x minus 4 cubed. You okay if I go the 18th?
Yeah.
Multiply the tops and multiply the bottoms. So we're going to go an 18th of 7 take 4, I'm going to bother writing down. Cubed minus an 18th of 1 minus 4 cubed. So it's an 18th of 3 cubed minus an 18th of minus 3 cubed. Oh mate, yeah, you had me panicking there. 27 on 18, yeah?
Yeah, plus 27 and
Plus 27 on 18, which is 54 on 18, which is 3.
Oh.
Which is nice that it works. So does that prove it to you? Now, here's 2 things in life for me. You can prove it sometimes, or you can demonstrate it. So sometimes the proof's so annoying I'd rather get you a picture of the demonstration rather than a picture of the proof. Does this course even mention, I don't think it even mentions it in the syllabus.
So B minus A on 12 or squared will always work.
Nice little shortcut. Will always work.
Does
Now
that-
I could try to go through the proof with you.
Yeah, can you
I
derive
could.
that from the integral?
Eh?
Would you derive that from the integral?
Yeah. So we could start the proof, but then when I looked at my starting the proof and I looked up YouTube and how they started the proof, they did a twist that I want to see if I can get it my way, but maybe you can't get it my way. But the concept for me is, are you comfortable that it's a demonstration that's true? It doesn't prove it's true, but it's a demonstration. Of course you can walk in the exam and it's true and you can use it. Yeah? But now we can talk about proof if we want to. But first of all, there's a formula I never mentioned here. Why? Because I didn't know it existed until about 12 months ago.
12?
Yeah, why 12? Now, if I can go through the proofreading, you can see where the 12 comes from, and that 12 will always be there. And you go, why?
Do you know why?
Not fully no, but yes, I can see it on the proof that it ends up being a 12. Does my brain comfortable of why it ends up being a 12?
No.
So imagine when I first saw it, I just went, they're talking a load of rubbish. Then I did it a couple of times and went, oh, that's right. Yeah, interesting.